Well, hello and welcome to a Dev Nation Master course that we have today. We're going to be talking about Kubernetes. We're going to talk about Kubernetes today and tomorrow, as a matter of fact. We're going to show you the more basic items today, and we're going to dive deeper even tomorrow. So be ready for that. If you're not signed up for tomorrow, make sure you sign up for our Kubernetes 2, which is a part 2 of 2. So there's 2 of these sessions. We're going to be running for about 1 hour today, and as well as 1 hour tomorrow. And you'll notice in the slide deck, there's even homework. So you should try the homework out, and then you might have more questions for tomorrow. Now, we're going to be going live, fast, hard in the session. Do use the chat. You see that there's an active chat that's already moving along there. That's where you'll find links, including links to things that I might find important and want to send to you. And you'll also have Sebastian and Alex and Edson there and other people to answer your questions. And so feel free to throw all kinds of questions into the chat. I have some real-time polls I'm going to run with you guys, and we're going to be coming at you fast. So there's going to be a ton of things going on. Now, there's a large audience today. So hopefully we can keep up with all the questions and all the chat. But if you would, just try to keep the chat focused on, questions and real technical topics, and that'll help us get through this process. But I thank you all for being here today. There's a massive crowd. I mean, I see Peter, Pablo, Oscar, Arun, Rick, Dan, Nabi, I think Nabi, it might be right. Juan, Prasad, right? All of you guys here, fantastic. Thank you so for being here. Leonardo, Mohammed, Jim, DJ Maddie. That's a great name, by the way, DJ Maddie. I like that one. All right. Yasleen, Yulissa. Or did I get that right? Maybe I got that close. Okay. So good big group here today. We're going to have a lot of fun. We're going to dive into this. So let's go and get started. I'm going to go ahead and basically share my screen with you guys. You guys get to see my messy desktop here. I already just sent you the link to what the back end looks like. So I sent out a tweet. So this is where I'm sitting right now. But we want to also, let me go ahead and give you access to this tweet. This is a fun tweet where I basically have been fun with recording in the recording studio and editing there. I'll give you that one. But I actually have some questions for you guys. Okay, so I have some questions and I'm going to give you this link right here. And let's do this. And let me go add the link here. Okay, some questions will help us level set a little bit to see exactly where people are right now in their journey when it comes to Kubernetes, comes to learning Docker, things of that nature. Also, do let me know in the chat if you feel my audio needs to be a little bit brighter, hotter, more gain, if you will, or if I'm a little too loud, I can tune that up and down. Got a different microphone I'm using than before. But let's see what your personal experience is from a Docker standpoint. How many people here have spent some time with Docker? It looks like we got some votes coming in right now. So 8 people, 10 people never touched it. Some have been hands-on but not using it regularly. Okay. So it looks like the yellow here is kind of the winning this little race right now. So people have been hands-on with Docker, but not using it regularly, and that's very fair. And you will see some aspects of Docker when we get into the Kubernetes aspect of it, because you have to build your images. Now, we'll be focusing on image building in the second session, tomorrow's session, not today's session. But you should appreciate what Docker can do, because you at some point will have to craft an image that gets deployed to Kubernetes, and the Docker tool is the primary way you would go about that. All right, that's fantastic there. All right, and then let me see if I can get here to this next question. What is your personal experience with Kubernetes, right? So if you could answer that one for me. And I'm going to imagine that if you don't have much experience with Docker, you're not going to have a lot of experience with Kubernetes. So you can kind of see that chart going up and down there. All right, so a lot of people read blogs and watched some videos. Today you're watching a new video, a live stream video about Kubernetes. Some people have been hands-on with it. That's fantastic stuff. That's really good. Awesome. Really good. Let me check out the chat over here. Looks like you guys are doing a great job answering. Okay. Well, you got to be answering not in the chat, but on the real-time poller here that I'm trying out for the first time. Okay. Fantastic. Use Docker briefly. All right. A little more audio. We can definitely make it a little bit louder, and push it into the yellow zone. We're in the yellow zone at this point. Okay. But here we go. Let's get into this now. All right, so it looks like most people are the right people to be here today, because if you've only read blogs and watched some videos and things of that nature, we're going to show you all kinds of Kubernetes stuff from scratch, all right? We're going to show you the bare bones basic today to get you started with that. So what I want to do is actually show you a little demonstration up front, okay? A little demonstration up front, and it's this one right here. And let me give you guys the link in the chat, okay? So you guys can also talk to this application for me. This is an application. I'll just put my name in here and it'll say Aloha Burr, and it comes from AWS. But what this is an application that is deployed across the hybrid cloud. What this means is I have an application that's built one way and deploys across all cloud providers. Right now it's running on Amazon, and you'll be interacting with the Amazon version of it. But because this is a Kubernetes and OpenShift based application, you can run it anywhere. All right, that's the key thing. You can run it anywhere you want to run it. And in my case, I do have OpenShift running in all three areas. You guys go to that link though in the chat and add some messages for me. Let's see here. All right, yeah, adding some. There's Sandro. There's a hi. Fantastic. You guys are adding the messages for me. But what I'll show you what I have here on the back end. Okay. So what I'm talking about now is I have my OpenShift cluster running on EC2. And so you can kind of see my OpenShift VMs here, or the EC2 VMs running in Amazon. And this is what my OpenShift cluster looks like. So this is my Kubernetes sitting on top of that EC2 environment. I also have my Azure environment running here. So this is my Azure, and I have my Kubernetes sitting on top of that, okay? And then I also have Google, my Google backend here. This is my Google VMs running, and my OpenShift running on top of that. Now, I have these in different locations. My Amazon's running in Ireland. I think my Azure is running in Texas, and I've forgotten where I put the Google at this point. But you guys should just be familiar with the idea that if you build an application the Kubernetes way, the OpenShift way, you can run it across any cloud. And that's one of the key aspects of this. So let me kind of go in here, and let's actually see how you guys are doing here. Punching in messages. All right, more messages in that item there. Okay, so there's more messages. Looks like we got 144 messages in, 145. You guys are putting in the messages for me. Again, the link right there. But here's what I want to do. I want to actually, let's resize this window a little bit. Okay, make that about that right size. And let's resize this one a little bit. And what I want to do now is I want to come here into this application and show you something. Let me go into the back end here. I'm going to turn off the back end responder. So right now, AWS is responding to you. And if I turn that off, all right, this is a pod. We'll explain pods in a little bit. If I turn that pod off, basically I killed the server. There's no more application server running with that back end anymore. So if I put in one more message here, I can't even spell message correctly, but if I put one more message in, you notice it fails over to GCP, Google Web, all right? Google Cloud Platform. There was also one that actually sporadically jumped on Azure. What we have is load balancing across the three cloud providers. So basically I have an OpenShift running on three clouds. And because we have this other technology called Scupper, and I'll just kind of give you the web page URL for that one. It's called scupper.io. And actually let me add it to the chat so you guys have it there. Where'd my little chat session go? It's easy to lose it. Okay. So if I put Scupper on this application, now that means I can actually load balance across the multiple clouds. In this case, I failed over from Amazon to Google. Amazon running in Ireland and Google running somewhere in the US. Like I said, I forgot. But I put Google in Bangalore on a regular basis. Let me go to my Google system. Let's come over here and go to my Google system. And if I come into this environment, I will basically find the back end here, not that one. Let's see here, find this other one, that one. Let's turn off the Google now. So let's shut down the Google server. And you can kind of see there's Google going away at this point. And so if I put another message here, so Burr was here, okay, you'll see that Azure is the only responder. And so Azure will be responding to your messages also. So I want you guys to keep that in mind, right? If you build an application, it's easy to deploy across the hybrid cloud. And of course, in this case, I'm using OpenShift across the hybrid cloud and all three public cloud providers. But I'm also using the Scupper technology to do the real-time load balancing and failover, which is pretty awesome stuff. Okay, so you guys can play with that application for a little bit longer. I'm actually going to go back now and check on our poll. I'm curious to see what our poll was like here. Okay, so most people have very limited Kubernetes experience, and that's very fair, and that's why you're in the Kubernetes 101 session with us today. Okay, you've been hands-on with it. Very few people using it in production. In my case, I'm running the little application in production. All right, so that's where we're going to be, is focusing on the basics of Kubernetes. So let's go ahead and dive into this material and make sure you guys have access to the slide deck. So make sure you have access to the dn.dev, kubemaster1. And let me find my chat one more time. I'll make sure you guys have access to that. Okay. You guys want access to that? And then there's the homework. You want to access that also. So make sure you check out the homework. Because when you guys go and try those things, you'll have some fun with that. Okay. And as a matter of fact, I'm actually going to, now I think about it, let me actually come over here back to my little demo application. I'm going to turn the backends back on. So that was the Google one that I turned off. Let me come over here to the Amazon one that I turned off, and let's turn that back on too, so you guys can interact with it a little bit more. Okay. All right, let's get into this thing now. You guys have access to all the links, at least the important ones, and we're going to dive into this and have some fun. Okay, now, this is the Kubernetes Master Course 1. There is a number 2 that's coming tomorrow. Keep that in mind. And we're going to be moving pretty quick, but you also have the chance to try the homework out and then, of course, meet us again tomorrow. Now, there's a whole bunch of these things scheduled. We're not going to just be running it today. We're going to be running this again and again and again. As a matter of fact, we're going to be running this in an Asia-friendly time zone in English next week. So next Monday, Tuesday, we're going to run it earlier in the morning if you're an American, but actually in the afternoon if you're living in India, as an example. So if you're living down in India and Australia and Singapore, and you know you have friends and family there, let them know they can also take this course in that time zone. We'll also be running a French version, a Spanish version, and the Brazilian Portuguese version just happened a few moments ago. So we're going to get these schedules set up, and you can go to the schedule and see exactly how to register for these things. So just keep in mind we're going to be running those. These sessions are primarily going to run Monday, Tuesday, Wednesday. We will be adding Quarkus to this training schedule starting in May. We'll also be adding an operator class starting in May. But you kind of see we have Istio, Knative, and Tekton also up and coming. We have a Thursday session that you should check out. So every Thursday, we're now running a session. You can click on the link there to go find out more about Java running in a container. We have a bunch of AI/ML stuff set up. We have things related to Debugging. We got Ansible. We got all kinds of things we're getting set up for the Thursday session. So just be prepared for that. Okay, this is me. You can follow me on Twitter, and you can find me on Twitter and things of that nature. You can also hit me at this email address, bert@redhat.com. That'll find me there. Do come chase me around if you have questions. I'll get to them as fast as I possibly can. Also, feel free to check out our ebook there. You can download it for free at the developer program and learn more about Istio, and of course, show up for our Istio class, which comes up in a couple weeks' time. Okay, there is a survey link, and let me go ahead and add this link to the presentation, the chat. Because I want you guys to give me some feedback on this. You know, is this type of thing working for you or not working for you? Whoops, let me paste it in correctly there. Okay, right. So we're gonna run that. It seems the number one question is how long are these sessions? That's the number one question I've gotten from every point of view at this point. Okay, so here's today's agenda. We're already 12 minutes in this. We got to keep going here. Today's agenda will come on Google Docs. There we go. Google Docs loading slowly there. All right. We're going to basically talk about what is Kubernetes, why you care about Kubernetes. We'll blow through the installation part of it. You can do the installation on your own on Minikube on your local laptop. But we're going to definitely dive into kubectl, what a pod is, a ReplicaSet, a deployment is, Stern, and things like logs and things of that nature. So debugging. And we're going to try to cover as much as this is possible in this first course. Now, tomorrow, there's a whole other course, right? It's Kubernetes Part 2. In Part 2, we show you how to build those images that we use in the first stage. We talk about resource limits. We'll talk more about live and readiness probe, service magic. And I call that service magic because we have a lot of fun with the Kubernetes service. A lot of really fun things to do there. We also will dive into things like the environment and config map and secrets if we have time. And I definitely want to finish with CRDs tomorrow, custom resource definitions, because that'll help you understand how all that other magic works. So the Istio, the Knative, the Tekton, all that is based on something called custom resource definitions. So you can see in just 2 hours time, we cover the full gamut of pretty much a great intro to Kubernetes class, and you have the documentation to go try on your own. So definitely check that out. But let me do this right now. Before we get too far into it, I just want to go ahead and kind of show you how this thing's going to run. I want to do as much demonstration as possible. So let me do this real quick, and then let me see if I can find the notes that I had here. Okay. All right, not that one. But this is the tutorial, right, that we've been talking about. You'll see links to it throughout the presentation. And we have you go through and do all these different exercises, right? So you want to run these things on your local host environment with Minikube. In my case, I can run it on Minikube, or I can run it on a hosted cloud as an example. But I have all these OpenShift instances, all these Kubernetes instances, as I mentioned. So I have my kubectl cluster info running here on Amazon. So you can see there's my Amazon instance. There's my Azure instance. And there's my Google instance. Oh, let me say kubectl cluster info. Okay, so I have my 3 big Kubernetes clusters running in the public cloud across those 3 different cloud providers. And again, I can run them around the globe. But I also have my Minikube over here. And let's try it real quick. So kubectl cluster info. Okay, so one thing you should be aware of right away, this kubectl tool is one you're going to be with a lot. This is going to be your favorite 7 characters to type on the keyboard on a recurring basis. As a matter of fact, people use this command so often, they've mapped it as an alias with K, right? So you'll see the K letter sometimes used there also. Okay. All right. So here we go. We're going to dive in a little bit further and show you some other things though. What I have running right now is a little application running on my Minikube. Let's kind of walk you through how I set this up. I'm going to jump over to my Google one just for the sake of doing it. And I'm going to say kubectl create namespace, and I'm going to call this thing Burr for lack of a better term, right? Just make it Burr. I have a special tool called Kubernetes to map it as my default namespace. And so now I'm interacting with Burr. If I say kubectl get pods, there are no pods. If I say get all, there's nothing in this thing, right? So again, kubectl get this, kubectl get that. That's the tool you're going to work with a lot. I can see though that there are tons of things running across this cluster. Okay, so right here I can see there's a ton of different pods which represent the OpenShift environment sitting on top of a bare bones Kubernetes. So if you think of a bare bones Kubernetes, it has things like etcd in it, an API server, and that might be it, right? Like if I go to my Minikube over here, it actually doesn't have much going on in it. kubectl get pods -- all namespaces. So a bare bones Kubernetes like this one has core DNS, etcd, and API server. We'll talk more about these in a second, right? Storage provisioning, but it does have my 3 little Spring Boot apps over there. We'll go check out in a second. But a big time Kubernetes coming from a real player will have all sorts of fun things in there. All right, but you're going to be interacting with these things called pods a lot. So kubectl get pods will be your favorite thing that you'll type. You're going to actually type that in your sleep. You're going to type it all the time. Okay, so let me actually check out I'm going to kind of take a peek at the chat here, which is going bonkers. Can you run OpenShift on Minikube? No. So Prasad, you can't run OpenShift on Minikube. OpenShift is a separate distribution, like Minikube is a distribution of Kubernetes. OpenShift is its own distribution of Kubernetes. You can run an OpenShift on your laptop. It's known as CRC, and it's in the slide deck. You'll see a download link there. Okay. We got the links in there. Dun, dun, AMIs, no AMIs here. There's a special installer to install OpenShift on top of Amazon. You can go to openshift.com/try for that. So I see that question from Rick there. Okay. All right, well, we're going to keep going. And let me find, I actually lost a page around here someplace. Let me find it. There we go. Okay. Yep. All right. And so I'm just looking at the same documentation I want you guys to check out. All right. So I'm just going to give you a quick demo of kind of the basics, and then we'll dive into how and explain this a little bit more. So get nodes here. kubectl get nodes. You can see I have a bunch of nodes. Think of these as my worker nodes and master nodes. We'll explain that more in a second. And on Minikube, if I look at Minikube and say get nodes here, Minikube has a single node because it's a single node running on the laptop versus, let's say, a real cluster, in this case running in US Central on Google Cloud Platform. All right, so different environments there. And you can look at everything across from across the world, but what I want to do right now is just run a quick deployment. Okay, I'm going to copy and paste this in. And let me do this real fast. Let's do get pods. kubectl get pods. Oh boy, I can't type today. There we go. Get pods. And actually, let me also monitor for events. We'll talk more about this in a second. Okay. And I just want to deploy something real fast. I want to just deploy a little application just so you can kind of see it kind of work, do its magic. All right. So this kubectl create deployment basically is going to pull this image. So Quarkus demo 1.0.0 from Quay.io instead of Docker.io. It's going to pull it from there. And if I open this up a little bit more, okay, you can kind of see the events that are happening down here. So you can kind of look right now, you can see it's basically pulling that container, and then it will have successfully pulled, right? So pulling and pulled, and is that running off the screen a little bit now? Okay. And then when it gets that image pulled, it basically will get it running. And so you can see 1 of 1 running right here. And that is basically running that image, my little application server now running as a pod. Okay. So the command I just used is a shortcut, and actually one you won't normally use, but it does allow you to test your image quickly and see if it's working. And then the next trick you'll want to know is you'll want to be able to exec into it. Okay, and again, we'll talk more about this in a second. And then you can basically shell into that pod and then curl localhost, and let's check it out. Okay, so I can basically verify that the application is running. And then I can basically exit back out of that, back to the main terminal in this case. So getting an application up and running is not that hard. You will be learning about these things called deployments. You will be learning about these things called replica sets. And of course, you're going to spend a lot of time learning these things called pods. Okay, so pods, kubectl get pods is your favorite tool overall. One thing also I'll show you here is let me expose, create a service. Okay, so kubectl get services. And here's my service coming up. And let's actually do a watch on it. Kubectl get services. And I promise I'll slow down here in a minute and explain some of these things. Right now I'm just trying to show you what we're trying to cover here in the next 40 minutes or so. So right now I have my pod up and running. I have a service that's I'm waiting for the external IP to be assigned. But the service represents the front-end load balancer across those pods, okay? So you can have multiple pods representing the application components, and the service is the IP address that the users will interact with, okay? And of course, the service can then also have an external ingress, like a route based on HA proxy or something like that. In this case, I'm just gonna look at the service directly. And it does take a little while, especially on the cloud platforms at this point in time, to get the IP address assigned. While that's happening, let me take a peek over here at the chat to see if the team here is keeping up with everybody here. Okay, where do you have the master running? So if you run OpenShift in a public cloud, the masters need to be near the workers, and the masters have to be near each other. So I don't know if that was really the question there you had, Krishna, but you do want to keep your masters and workers all together. We'll mention that more in a second. Let's see here. The recording will be available. This URL is in fact your recorded URL. Okay. You got access to the books, you got access to the slide deck, and I think you should have access to everything. Okay. Now, there's my external IP address. We've found a way to talk long enough that came through. So let me clear here. And if I say curl and then 8080, all right, let's see. And it does take a little bit longer after the IP address is assigned to then make it resolve. So we need to basically, there we go. Okay, so now I have my supersonic subatomic Java with Quarkus running right there. So if I say, let's do this, let's do a while true. Okay, while true, do curl, put that in there, not twice. Okay, 8080, sleep for a moment, and done. And there we go. So we're basically just looping against that pod, interacting with it. You can kind of see what it looks like right there. And let me show you one other quick trick. Okay, I'm going to kubectl edit deployment. Let me figure out what my deployment name is. Right here. All right, it's my app. So kubectl edit deployment my app. And again, all I'm doing right now is giving you a quick overview of the stuff we'll be playing with today. Okay. All right, so I'm going to make this replicas 3. I hit save and close, and that'll cause more pods to spawn. Because your replica count is basically how many pods do I want of that image type, if you will. And so I'm going to get 3 supersonic subatomic Javas running. You'll notice that the actual host name actually is changing here, right there. And that represents the pod identifier. So there's that pod, and there's a count in there. So you can kind of see there's my supersonic subatomic Java running. And I can even go a little bit crazier with this. Let me go edit the deployment one more time. And let me change it from Quarkus over to Spring Boot as an example. My boot, and let's call this v1. So I'm going to go to a Spring Boot image and hit close. All right, and let's see if it does its rolling update correctly, if I did things correctly there. Basically, I just changed the image that the deployment is mapped to, and that tells Kubernetes to do a rolling update to the new image. So right now, it's really trying to basically spawn new pods based on the Spring Boot image. You can see the container creating here. And when it gets it up and running, it then rolls over the user traffic to it. So you can see it went from supersonic subatomic Java to Aloha Spring Boot, and it's still got some supersonic, some Quarkus in there as it rolls over everybody to Spring Boot. Okay, so even if I actually gave you guys this IP address, and I guess I should have done that, right? You could have done the same thing, right? So here, I'll add this to the chat. You guys can interact with this also. Okay, there we go. Okay, so that's the same thing that I'm running. One thing I'll show you, though, is that you will want to understand, and that is, let's see here, kubectl get services. I've switched over to my Minikube, by the way, and let's see here. So Minikube, you have a different setup on Minikube, like you got to go to that. So let's go to while true do curl, grab this IP address, okay, and then I'm going to use the node port here. So it's a little different setup to get access to it because it's running inside a virtual machine. 3.3 and then done. Let's see, there we go. So there's my Spring Boot app running on Minikube, and I want you guys to see this one thing. So if you were not paying attention, pay attention right now. This is important. Let's see, get my deployments. Let's make sure my deployment is correct. kubectl edit deployment. My app. Okay, my app, and then let's go to that image. I'm going to make it v2 of Spring Boot. So do the rolling update to version 2 of Spring Boot. And I want you to watch what happens here. It's going to go through the process of going from aloha to bonjour. And you notice I'm getting error messages here. And this is going to become important when we do tomorrow's session. So we're going to actually start tomorrow with this problem and then tell you how to fix it. Okay? You notice there was downtime. Our user saw an error. And I'll explain what that is tomorrow. So just be aware of that one. Okay? In the number 2 session. So if I go back to version 1 here, hit save, and watch it roll back the other way. So it goes from bonjour back to aloha. You'll see the errors again. All right, so that's more an advanced technique, but you guys will get a chance to play with that tomorrow, okay? All right, let's kind of come back to our presentation now. And let me double check. Let's see. Didn't get my Kubernetes open source. All right. Okay. Let's actually jump into here and talk more now. Now that you guys have you basically have seen the whole session in a few minutes. But let's go ahead and walk through this a little bit more slowly and double check that you guys have a good understanding of some of this fun stuff we showed you here. All right. The reason Kubernetes has become so popular and has basically exploded into the scene is we no longer have single monolithic deployments where we deploy everything once a month, once every 6 months. We deploy the whole big thing every 3 months, right? That old model of deployment of a big thing every 3 months or every 6 months is no longer part of our world, right? We live in a situation now where people want to deploy every day. They want to deploy every hour. They basically want to break up that monolith into multiple microservices and deploy it into, let's say, 20 times a day or 100 times a day. In order to do that and manage that level of complexity, that's where something like an OpenShift and Kubernetes really help you out. All right, so keep that in mind. So the new school way of many deployments, many microservices, that's really Kubernetes and OpenShift really make a big difference. So the challenge we had in the old way of doing business, if you guys are familiar with Java, hopefully you guys are familiar with Java as a whole, and if not, you at least probably have the same issue with other programming environments, is when you actually built your artifact for deployment, you might have actually talked to the file system. You might have had a / or / in there, and therefore you might have blown that up if you move that application code from Windows to Mac or Windows to Linux or Windows to Solaris, right? In my case, I did a ton of Windows to Solaris back in the day, and so that / versus / would definitely mess you up. Okay, or if you misspelled the Jindy name, or you had the wrong patch level of the Java virtual machine, or you just simply had a different, flavor of your Windows environment from your Linux environment or your Unix environment. So we tried to figure all that out, right? We basically had to deal with all this custom configuration, the application server that was involved, the JVM, the operating system, and what we did is we wrote this down in an email. Okay, we sent an email out to everybody that said, "Here's how you configure the system to run my application." So a good developer wrote a good email, and hopefully the testers figured out how to replicate that environment, or hopefully the production team, the systems administration team, figured out how to replicate that environment. But the challenge was it was very different worlds, right? I typically did development on a Windows 7 machine, Windows 95 back in the day, and of course moved up to Windows Vista, if you guys remember that. But I did my development on a Windows machine, but production was often Solaris, in my case, or HP-UX, or DG-UX, or all kinds of different UXs back in the day. And of course, nowadays, it's pretty much Red Hat Enterprise Linux, right? So Red Hat Enterprise Linux tends to be the production environment. So I want you guys thinking about that, because the reason we've gotten so excited about this thing called Docker is because it helps us solve that problem. Instead of having an email codify how people should interact with our application, we have a single file we can check in the source control. So the Docker file allows us to say, what is the base operating system? What is the application server that's installed? If it's not an application server, what are the libraries I need, like Java Virtual Machine, a Node.js runtime, a Python runtime, different libraries for my C++ application, or different configuration. Like in the case of this little example here, I might have my web app server configuration in XML that I have to map over. So all the different configuration things you need to run your app were codified in this thing called a Docker file. So the Docker file was a game changer for us as an industry. Now here was the real next trick. That once the Docker file solved massive problems for us, we then had to think about, well, how do we run that Docker container at scale? And so a lot of people still do this to this day. They will do a Docker build and do a Docker run, and then that's on machine 1. And then if they have a second machine, they do a Docker run. If they have a third machine, another Docker run. And if here I have 6 different machines, so Docker run, Docker run, Docker run, Docker run, Docker run, Docker run. And if the process ever dies, they come back around and do a Docker run again. So we've actually, in many cases, have created all this interesting stuff to basically monitor those Docker runs. 1, get the Docker run to execute. 2, monitor the Docker run to see if it's still running. And if it fails, Docker run it again. Now, humans can do that, obviously manually, or you can let Kubernetes do that, right? Kubernetes is doing all your Docker run, Docker run, Docker run for you. Okay, so Kubernetes makes a lot of this magic happen. You can see there's a link on the slide deck, and hopefully you have access to the slide deck at this point. All right, the term Kubernetes comes from a Greek term. It means like helmsman or governor. I like to think of it as the pilot, the captain of the ship. Think of it as the, admiral of all the fleet, if you will, in many cases, right? Kubernetes has helped you manage all those different containers at scale. It came from the Google world, right? So Google's experience with containers. Google loves to say that they've launched many containers, millions of containers, and actually billions of containers a week at this point. All right, let's see here. Okay, so in the CNCF world, the Kubernetes thing has exploded. So it used to be Kubernetes was a fairly simple thing, and they got moved over to this organization called the CNCF, the Cloud Native Computing Foundation, and the world has blossomed around Kubernetes. Everything now attaches to Kubernetes. You want special kinds of storage, special kinds of networking components, anything software defined in a software-defined data center kind of way now runs against the Kubernetes backplane. Kubernetes is the new engine, which represents the new data center for in the public cloud or in the private cloud, or even running on a bunch of Raspberry Pis. Doesn't really matter at this point. You can run Kubernetes and OpenShift pretty much everywhere. Now, I'm taking you back to history. I like history lessons in a lot of my presentations because it helps to have some context. And we've been thinking about how to break up our project teams for many, many years. Like, what did it mean to go to extreme programming or an agile, right? The Agile Manifesto. We've tried to break up project teams and project deliverables in smaller chunks. Instead of having a 6-month project deliverable, we went to sprints with maybe a 3-week project deliverable or a 1-week project deliverable as an example. So we broke up teams and we broke up project cycles, but now we have broken up the software itself. So instead of having a 2 million line code base that we try to deploy every week, we have maybe a 100,000 line code base as an example. So that's where the microservices principle came from. And microservices really took off here in 2013 and 2014. So when Spring Boot and Docker came onto the scene, that's really what really made microservices go. So we already had Hystrix, Eureka, and Ribbon from the Netflix team. We already had a definition from the ThoughtWorks team about microservices. We had DropWizard and VertX, which showed us how to do microservices back in 2011. But it was really 2013 and 2014 when Kubernetes came onto the scene and Spring Boot and Docker and things like microservices was officially defined. So basically things really blew up in 2014. I make that point though because in 2015, we actually decided to show the world Kubernetes for the very first time. So Red Hat was the first organization to take Kubernetes to the enterprise, make it supportable by everybody for any organization. And we actually now have, a lot of customers running our Kubernetes in their production environments. But we decided to show the world that you could launch 1,000+ containers on stage. Okay, so that was our opening gambit, was why do you care about Kubernetes? Because you can manage these containers at massive scale. And we actually launched 1026, 1026, not 24, containers live on stage in 2.5 minutes to kind of make that point. We launched all those little application servers, and then we allowed the audience to pick a pod, right? They could put their little image on a pod. It was a really fun thing, and the URL to that is there. Okay, so let's talk about these terms in Kubernetes land, and then we're going to dive back more into the demonstrations. We're doing good on time, all right? So I think we're doing good on time. Looks like the stream is holding up here. I'm not getting any errors from my OBS system. Let's see here. Not getting any errors from my YouTube environment. That's always a good sign. So, we'll keep going here, okay? So on our pods, this term called a pod, where does it come from? People always ask, where does the word pod come from? And they actually think it's the pod people from the old Invasion of the Body Snatchers. If you're familiar with the 1970s horror film, Invasion of the Body Snatchers, there was the pod people, and people think that's where pods come from. They don't. That doesn't come from there. Or they think 2 peas in a pod, right? Pea pods. Well, that's kind of okay, right? Because you might have 2 peas in a pod. You might have 4 peas in a pod. And actually, depending on the pod you have and what part of the world you're in, you might have a bunch of peas in that pod or a bunch of beans in that pod. But really, I like to think of the term pod because of this one element. A pod is a group of whales. A pod is a family of whales. And if you're familiar with the Docker emblem, including a whale, well, there you go. There's a family of whales, a family of pods as an example. Okay? So that's the key thing to understand. The pod is the most important thing you're going to interact with because the pod is what runs your app. It is the process in which your application runs. So that's the most important element for you to interact with there. Okay? Now, some other key terms to get your head around. There's the pod, which represents the container. And it can be one or more containers, one or more whales inside your pod there. The pod, again, is your little machine, right? Think of it as your little computer. That's why when we do our little Java demonstrations or Node.js or Go or Python demonstrations, we actually show you the host name that code thinks it's running on, because the pod is the host. The pod is the computer from that Perl perspective, from the Ruby perspective, from the Java perspective, from the Node perspective, the pod is the computer, okay? It has a shared IP address, shared storage, a lot of shared resources, a shared lifecycle, right? So the pod is that computer, all right? Keep that in mind. You then can have a replica set or a deployment, which basically manages your pods. So the deployment replica set ensures that there's so many pods running. They ensure that there's a certain liveness probe and readiness probe, what's known as health checks. They want to actually manage resource limitations. They map in things like secrets and config maps and environment variables. So basically you will interact with this concept of the deployment and the replica set as well, because that is kind of the management tool, if you will, for making sure those pods stay up and healthy. And you'll see this more in a second. There's also the concept of the service. I showed that to you in an earlier demonstration. The service is your load balancer that represents the sticky IP address, right? The DNS entry that's more persistent. And you will basically have, a service that people interact with, and the pods will change out from underneath it. So one of the things I'll show you in the next session, in part 2, is that you can literally change the pod from behind the service so dramatically that you can change the programming language behind it. Like I want to deploy a Go application, a Python app, a Node.js, a Java app. It doesn't really matter. The service doesn't care. It's just load balancing across those pods. But your users are interacting with the service endpoint, right? Because that is the non-ephemeral IP address. It has the DNS entry. There's also the concept of the persistent volume and persistent volume claim. So if you do want to run a database, and apparently there was a MySQL question that came out recently. If you do want to run a database on Kubernetes, on OpenShift, no problem. You just want to use persistent volumes as opposed to the ephemeral storage. Okay? Ephemeral storage is what exists in a pod. You can write to disk in your computer, but that disk goes away when the pod gets recycled. The persistent volume is a shared software-defined storage environment, and you can map in different vendors' software-defined storage options there for persistent volume. But that lets you have shared storage that your pods can interact with. Okay, so if you have a database, Postgres, MySQL, Kafka, right? You would use Kafka with persistent volumes. And then our concept of labels. And the reason labels are so important is because it's kind of how everything in this world works. So we're actually talking more about labels in just a moment. Now, some other key terms when it comes to your Kubernetes cluster. You saw me earlier running my OpenShift on Google, running on Amazon, running on Azure, all right? And then I also have Minikube running on my laptop. Well, those all represent different types of clusters. And we call them clusters because they have different nodes associated with them. And a node is just a computer, right? A computer or a virtual machine. And so you have typically 3 master nodes in any good Kubernetes deployment. 3 master nodes because etcd, the database inside the master node, needs 3 for quorum, 3 for failover and fault tolerance and load balancing, right? So the etcd, in order to be happy and whole, needs 3. So you typically have 3 masters in most of your Kubernetes deployments. Now, in the case of your Minikube, you don't have that, because Minikube is an ephemeral environment where you build it, destroy it, build it, destroy it. It's for a developer laptop, or you can use it for CI/CD solutions too. Some people run it as in their pipelines, but basically it's there to basically build it up, do some things, tear it down, build it up, tear it down. Your real cluster, you don't want to build it up and tear it down all that much, right? You know, you typically leave your cluster running for a period of time. And so you typically have your 3 masters, and then you have n number of worker nodes. In this case, on my diagram, I have 6. You have as many worker nodes as you need to run your work. Okay, so just bear that in mind. People often ask, well, how many nodes do I need? Well, you need as many as you need. Okay, you need 3 masters and n workers. Okay, so it might be you only need 1 worker because you have a very small little application, in which case I'm not sure why you would run Kubernetes. It's kind of overkill if you only have 1 worker node, but maybe it's a massive worker node running a GPU. Maybe it's a 2 terabyte of memory or something like that worker node, in which case you kind of run a lot of stuff on it. But that still wouldn't be the smartest way to go. Typically, you'd want multiple worker nodes in many cases. And if I go back and look at just back over here to my command line, like if here's my OpenShift on Azure, kubectl get nodes here, you'll see I have a bunch of nodes running on my Amazon one. There we go. So I have you can see I've got multiple workers and multiple masters there. And it's been up for 7 days now. I'm running apparently Kubernetes 1.16 on that one. Okay, kubectl get nodes here. I have a different set of worker nodes running on Azure. And so there you go. So I have my 3 masters, 3 workers. And I have if I do my kubectl get nodes, well, it looks like I'd run that recently on Google. You can kind of see I have my 3 masters and I have 2 workers. 1 worker is misbehaving right now. I need to go figure out why it's not happy, as an example, but the system still runs, right? So there is some fault tolerance built into the fact that you have multiple worker nodes. Let me open this chat, by the way, and keep it over here so I can kind of keep an eyeball on it. Okay, let's see. No firewall to communicate between services. Yep, so Alex made the point of no firewall between services because services are all running within the same network. And basically, it's a flat network all running in the Kubernetes cluster from that perspective. As in the host has a amount of persistent storage, right? So we talked about the fact that PVs are your persistent storage, and you basically you can share them across multiple pods. Keep in mind the pods are ephemeral, so that's why the storage needs to be separated from it, okay? Let's see, what else do we have here? Dun, 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 covers volumes. Now, we don't actually have much time to cover PVs in this case. I will update the Kubernetes tutorial documentation, your homework, with a PV example. I just haven't had time, okay? I will get to that soon. But basically, the PV and PVC allows you to basically, mount a disk for all intents and purposes. All right, cool. But good questions there. Thank you, Sabine. Feel free to keep throwing questions at us. Alex and Sebi are trying to give you answers as fast as we can go here. There's a massive number of people with us today, so the questions can come in pretty fast and furious. Okay, so my cluster is made up of all these nodes. My developer and my operations person can interact with those, interact with it this way, right? So they interact with the API using that kubectl command line tool, or they could go directly at the REST API. They can interact with the API. They will basically say, hey, here's my YAML document, which represents what I want, my desired state. And that desired state, typically shows up in the form of a YAML document. And I just basically said something very simple here. I want this image, my Tomcat image, version 1, to run 4 times. I want 4 replicas of this Tomcat. And the reason I want 4 replicas of Tomcat is because I want some failover and load balancing. And I just want to have some fault tolerance in my system. So that's why I picked 4. And then when I basically send that YAML document over to the API, it gets persisted in etcd. And then the schedulers and controllers kick in. And they basically say, well, where can I run my 4 Tomcats? And it knows based on this kubelet, which of these worker nodes has capacity to run the Tomcat. Okay, and it will place the Tomcat out there. So my 4 Tomcats will spawn on each of the different nodes, and you can decide exactly can I have more than 1 Tomcat on a single node, and you can decide, nope, I only want Tomcats across different nodes. You can kind of pick and choose your affinity and anti-affinity rules there. Again, that's more of an advanced concept, not time for that today, but you could do that, okay? Now, if a pod fails, Kubernetes knows you want 4. You said I want 4, so Kubernetes will monitor that situation. If it sees one of the Tomcats dies, it'll respawn that Tomcat someplace else. So you kind of see it jump down here to the bottom because it knows 4 is the magic number. And if it can't find 4 in the cluster, it makes sure the 4th will run someplace else. So this is already a massive win. If you think about this from if you're a developer, and most of our audience is developers, if you think of it from a systems administrator standpoint, one of the primary things a systems administrator has to do is restart stuck JVMs that are basically hung up, okay? That's common. Java virtual machines get hung up a lot, depending on how bad our code is as a developer. And the other thing is restarting processes to die, right? Oh, the process died. Our monitor lets us know. We go restart the process. In this case, both the things are automatic with Kubernetes. Stuck processes get rebooted automatically, and dead processes get respawned automatically, as an example. Okay, audit trails for this environment. So audit trails. Well, so one thing, Shri asked about audit trails. Yeah, you use the kubectl get events command, as Sebi points out there, but you also you can document all this, right? You can back up your etcd. You can determine exactly what documents flow into the system by using a good source control system. We actually, something called GitOps is a common thing now. So basically everything you make a change to for your cluster actually is saved in source control, and then the cluster picks it up from source control. So you always have a version of everything, of all your declarative state there, as an example. So that's a very common thing. Another thing a Kubernetes cluster will do, and this is dependent on your Kubernetes vendor, will handle node failure also. So if it sees a node die, it knows to basically respawn those pods someplace else, okay? And it might even respawn the node. Now, in the case of OpenShift, it'll do this for you, but some Kubernetes clusters may or may not do that, all right? Respawn that node. Okay, when it says get restarted, so Zubin, when it gets restarted automatically, yes. So the container is there can be multiple containers in a pod. Okay, each container represents a process at the Linux operating system level. So if you actually can SSH into that worker node, one of these worker nodes here, and you do a ps-ef, you will see those process IDs, and you can kill -9 them if you want. In which case, Kubernetes will restart it. Okay, meaning respawn it. So it is each container is nothing more than a Linux process, and it's just getting restarted for you automatically. Okay, it's monitoring. Best backup strategy. There's actually multiple backup solutions you can add to a Kubernetes architecture, and basically you just need to back up that etcd. That's the most important thing. Okay, back it up. But the whole GitOps principle is now taking over, where basically everything defining our cluster installation is basically now in source control, and we keep all that in source control. And if we have to respawn the cluster, we do it from source control. That's a new thing now. Yeah, if a pod gets replaced, it does get a new IP address. So very fair question, and that's why you don't rely on the pod IP addresses. You only rely on the service IP address, not the pod IP address. The pod IP address, just ignore it as if it's not there. Okay, let's talk about labels. All right, in the case of labels, this is a key element to understand. Think of these as name value pairs to get applied to all your different components, right? Your nodes, your pods, things of that nature. And in this case, you can see I have my app here called cool with an environment called dev and a version called 1. But I also have app cool with an environment called prod and a version 1, and I also have a version 2. So this allows you to select these different pods by basically saying, I only want app cool, and that gives you 4 different responses, right? 4 different pods. I only want the prod, right, version. I only want the dev version or the version 1 version or versus 2 version. So just keep that in mind. Labels are how you organize things within the environment. And so this becomes super important when you are working in a multi-tenant world, right? So in this case, I might have dev, stage, and prod all in one cluster. That's possible, though it's not as common. Most people do separate their pre-production from production with 2 different clusters in many cases, but you could mix them all in one. But often I have multiple teams working in a cluster, right? So in other words, I have the manufacturing software team versus the customer service software team versus the human resources software team, and therefore I will use these labels to make sure I can differentiate across those things. Okay, so labels are super important. Remember that. We're going to skip installation. You guys can do that on your own, and feel free to throw questions at us via Twitter or things of that nature, right? So we're going to skip the installation piece, but there's a lot of things to do from an install standpoint, and the install is the hardest part. Getting a Kubernetes cluster is the hardest part, right? And Minikube is my favorite because it's one of the easiest to work with. You can run it on Windows, Mac, or Linux, and it pretty much works consistently there. You could also just use the Docker. So like if I have my Docker running here, and it does have a little Minikube built into it, okay, you could use that. And a lot of people find that pretty popular. So, just keep in mind that you have all these different options to try out somebody's Kubernetes environment, okay? So you go definitely check those things out. Lots of different developer tools that you want to use. You'll notice our documentation uses Bash, so not PowerShell. We use Bash for everything, which is good for Linux, good for Mac, and so just be aware of that. You will see there's other tools you'll need here like Docker and Git. If you want to compile the images we've provided for you, you'll need a JDK and Apache Maven for compiling the Java stuff. And if you want to compile the Go, you need Go. If you want to compile the Python, right, you'll need the appropriate tool for compiling the example code. Curl we use a lot. You'll see that, and you saw it earlier in my demonstration. And so what I want to do now is kind of hop back into this thing, okay? We actually showed you kubectl already and showed you a bunch of that. But now I want to kind of walk you through more of the pod and ReplicaSet and deployment model a little bit more slowly here. So let me find my docs here, okay? And this is the documentation we provided for you. So you'll want to kind of work with the same thing. And let me see here. I am going to... Let me see, what do I have here? Kubernetes. I want to see what namespace I'm on. I think I called it Burr. I might have forgotten that already. Let's see here. Yep, I called it Burr. So I'm going to live in this Burr namespace. It doesn't matter what namespace I'm in. Okay, kubectl get pods. Let's see. Okay, let's do this. Kubectl. I'm going to get rid of the thing I did earlier. Delete deployment. I think I called that my app. If I wipe out the deployment, that removes the replica set, which removes all the pods. Okay, get kubectl get pods. So keep that in mind. Get pods. All right, so there our pods are terminating now. You notice the replica set and deployment disappeared fast, and the pods take a little time to go away because the pods represent those computers that your code is running in, right? That was a whole application running in there. So it takes a little while to clean that up, okay? You'll notice it takes a while for those terminating to eventually truly go away. So we're terminating now. All right, so now let's jump in here, and let me try this. Let me kind of run a naked pod. This is known as running a naked pod. And let me put my watch over here, kubectl get pods. Okay, here's this pod coming up now. So this is a pod definition running by itself. So no replica set, no deployment, and this is known as a naked pod. It is totally not recommended you do it this way, but it is the fastest way for you to basically say, hey, I got an image, and my image has been pushed someplace, and we'll talk about how to build images in the second session. Right? I got an image out there. I want to just run it on Kubernetes. I just want to run it on OpenShift and see if it works or doesn't work. So this is like the fastest thing you can do. All you got to do is come in here and replace this metadata name and replace this name whatever makes sense to you, and your image name. That's it. And you're off and running. And you kind of see there's my little pod up and running there. And I can know that it's running because I can do a kubectl exec it. Okay, and I'll copy its name, bin bash. And if I have a bash shell on that one, yeah, I do. Curl localhost 8080. And there we go. So my little Java application has sprung to life. It's running. All I got to do now is send user traffic to it. I have my little application running. Okay, so that is a little naked pod. Now watch what happens if I do kubectl delete pod Quarkus demo. This is important. If I delete the pod, it goes terminating, and it truly goes away because there is no replica set, there is no deployment, making sure it stays up and running. Okay, looks like the questions are still coming in fast and furious, but it looks like the team is doing a nice job answering questions there. Fantastic. Okay, so we can basically run that pod, exec into it, and you notice the instructions I just showed you, your notes are right here in this document. We worked really hard, and we work really hard to get our documentation so you guys can follow exactly what we do, okay? So you might think I'm moving too fast, but it's all documented. You don't have to make notes. Not to mention, you can come back and look at this URL in this video, watch it again with a pause button, and in my case, you want to take me down to like 0.75 speed, okay? All right, so let me run this replica set here. I'm going to run a replica set. That should bring some pods to life, get rs. So I basically have now created this replica set, and 3 pods spring to life now because if we look at that, it said replicas 3. So now you can see the replica set has a little bit more to it than just a regular pod does. A replica set is kind of the governor for multiple pods. And if you look at it from this perspective, kubectl get rs, kubectl, kubectl describe. So a lot of people say kubectl, some people say kubectl. The community has decided kubectl is more accurate. I'm just doing a describe here. Okay, and you kind of see what's happening when I do the rs here. Okay, it knows it needs 3 running, 3 desired, 3 running. It's using these labels. See, app Quarkus demo. So if I come over here and say show labels, you'll see there's the app Quarkus demo, env dev. So env dev, Quarkus demo, app Quarkus demo, env dev. So that's how it knows what pods belong to it. The labels. The labels are where all the magic works, okay? So labels are super important. The labels are how you know what pods belong to what replica set, how you actually know what belongs to what deployment, how do you know what service actually can load balance across multiple pods. All that is in the labels, okay? So let's go here, and let me see. We kind of did that already. And and here, watch this out. Watch this. Now, if I delete this pod, okay, I'm manually deleting it here. Delete pod, and I'm going to wipe it out. It goes away, and notice what happens. A new one springs to life in its place because the replica set is constantly monitoring and it basically says, I need 3. You told me you wanted 3. I'm going to make sure 3 are always there. Notice the age of this thing is just 12 seconds, 14 seconds, because it is a brand new baby bird that was just born. If I come over here to this other one and kill it, kubectl delete pod, wipe it out, you'll see it go away and a new one springs to life in its place. So you can basically keep killing these things and shooting them in the head, but they keep respawning. They're like bad zombies, right? You got to keep them down sometimes. But you can kind of see. Let me go delete this other one, the bottom one here. I want to delete it, but the replica set keeps it coming back. Okay, keep that in mind. So that is a core thing to understand about replica sets, and of course the nature of a pod. All right, let's see what else do we have here. And then here's the deployment, and this is a bare bones deployment. Let me kubectl get rs. Let me wipe out the rs Quarkus demo. Get rid of it. Delete. How about we delete there? There we go. And let me run this deployment now. And with this deployment, you'll see some pods springing to life. And so I have a deployment. I have a replica set. The deployment creates a replica set. The replica set creates the pods. Okay, kubectl get pods. There we go. How do you restart a pod? You delete it. Great question, right? That's what happened there. The pod is a container. The pod actually is mini containers, potentially. How do you know if you have more than one container in your pod? You can look here at the 1 and 1, right? 1 container, 1 pod. And they're both got to be ready. Sometimes you'll see 2/2. When you actually get to Arcane Native and Istio stuff, you'll see multiple containers in a pod. but more often than not, it's one container, one pod. But you can have multiple, and you will have multiple when you get into the more fancy, more advanced things like Knative, Istio, Tekton. Tekton, you can have like 12 containers in a pod. It's kind of awesome. Okay, let's see here. All right, so there's our deployment. Yeah, we got our deployment up. It brought up and it has the same principle because there is a replica set that was created. kubectl delete pod. If I want to restart that pod and clean it up, delete pod. I did something wrong. Oh, how about we don't say get, we say delete. There we go. So delete it. You'll see it spring back to life because the replica set and Kubernetes is making sure that stays whole. Okay, so that's your deployment. And again, you use your exec. You use your exec to get in there and see if things are okay. All right, use your exec to get in there. Let me show you service real quick. Okay, I showed you this briefly earlier, but so this is the service. It's looking for app Quarkus demo. Let me make sure I got things set up correctly here. App Quarkus demo. So you see these labels here on these 3 pods. Okay, those 3 pods. If I come over here now and map in this service, let's bring that service in here. kubectl get services. All right, and this is the service that's coming to life right now. I'm waiting for that external IP address. So let's actually watch it. kubectl kubectl get services. We'll wait for the IP address to be, that's the bottom one there, to be provided by the cluster. All right, but what I'm gonna do is show you something real quick right now. Okay, I'm gonna go into here. That's called the service, by the way. I'm gonna go kubectl exec it into this pod. Here's one thing that's kind of cool about a service. We'll see how close I am here. Curl the service 8080. Let's see here. Yeah. And these are on 8080, if I remember correctly. Oh, come on now. Resolve for me. Let's try it not on 8080. I can't remember. Oh, it's not on 8080. That's part of my problem. Okay, so check this out. I basically have, I'm using the service in a declarative way here. So remember I said it's a DNS entry? It's a DNS entry that all other pods automatically see. So when you want to talk pod to pod, you use the service by name, not the pod IP address, not the pod name, but the service name that basically is your load balancer. Okay, so now I can, if you watch closely, if I say curl the service here, it actually is load balancing across those different services. Okay, you can kind of see it hit this one, it hit this one, right? It's load balancing across the 3. And so I can also say curl localhost because it is in fact running this service, okay? Running that Java application. Let me get back out of here. And again, if I look at this IP address here and I say while true, do curl, sleep it for a second, done. There we go. I'm looping across it and I'm interacting with that service. So this service right here, get services. And if you guys were fast enough on the keyboard, you could be hitting that same service yourself with that IP address. Okay, when you delete a replica set, what happens to any transaction processing at that time? Basically, you're shutting down the JVM, right? You're shutting down the Python app, the JVM app, you're killing it. And so you can basically have another property in there that basically says, don't kill it too aggressively. Let it try to finish what it's finished before you take it down, as an example. Okay, so don't kill it too aggressively. It's not doing a kill -9, right? I forget what kind of kill it's doing. I should know that, but I've lost track of it at this point. Okay, let me see. We're almost out of time for today. You see, this time goes fast when you're hanging out with us here. But there's my service. You go. Here's how you could call it. There is also an ingress, right? So if you want to map this thing to a public URL for your users to interact with, you can do it that way. There's another trick that's actually built into OpenShift. I can say OC expose service. This is an OpenShift only feature though. So OC expose service. And if I say kubectl get routes, I now have this public route and I can curl against it. Okay. And then you guys can curl against it also. So let me actually add that to the chat right there. So you guys can go to that public URL. So an OpenShift route is basically based on HA proxy. It's our ingress controller built right in. We've had ingress long before there was an ingress, and so we call that the route as an example. Kill-term, graceful shutdown. Yeah, it basically does try to bring it down gracefully, and you can basically say, I need to finish some things before you shut me down. Okay, but you should also keep in mind too that all of these things are ephemeral in their nature, right? So this is definitely a cattle, not pets kind of world. So these pods kind of go up and down. The only pods you want to make sure kind of stay up are your like MySQL pods, your Postgres pods, things like that. And even those should be set up with 3 and sharing the same disk as an example. So one of the pods could die, the other two continue running, the users continue interacting with the database, right? So that magic number of 3. You'll see 3 Kafka brokers, 3 etcds, 3 Postgreses. That's a pretty common strategy there. Okay, and there's our OpenShift route. One last thing, and we're kind of out of time, that I want to show you though, okay? And this can kind of be important. There's a tool, one of the things you'll do a lot is you'll say kubectl get the pod or whatever. So let me say get pod, okay? And that gets the pod and gives it to you in this table form. But one of the things you'll do is OJSON, okay? And that gives you the thing in JSON form. You can also say OYAML. I prefer JSON in this case though, because JSON is a little easier to work with for this use case. So let me get the kubectl get route. And again, all this is documented. So I say get route, OJSON. And let me actually get the route in question, which is the service, OJSON. Okay, and see that JSON right there? What you'll do is you'll grab this JSON here, grab it, grab it, grab it. You'll take it over to a web page called JQPlay. You'll paste it in, and now you can figure out how to parse this thing. So you can say like status, I think looks like it's correct there. Status dot ingress, as an example, dot host. Nope, not dot host. I did it wrong then. Let's go back. Ingress, conditions, and host. I think it's host. I must have typed something wrong. Ingress, yeah. So, or ingress is an array. So let's try this. Maybe that's my issue. There we go. So now I basically can use the JQ tool to basically pull that thing out. Okay. So if I want just the host name, this is how you would write a lot of scripting here. So this is kind of a bash shell thing. So here I would basically grep and pass it through JQ. And did I copy that? There we go. And I did something wrong there. Oh, and I think you got to put this in curly braces, if I remember correctly. Oh, well, I'll have to remember that. But we did document this. The right here, spec host. Yeah, see, that should have worked. Let's try it. Dun, 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 dun. Oh, I know what it is. I basically didn't have to navigate through. There's also a spec host. I didn't have to go through status ingress. I could have gone through spec host. Got it. And got that data. All right, so definitely use JQ. There's also YQ as another tool there. But again, all this is documented. So what we covered today was installation, how to use kubectl, what a pod ReplicaSet deployment were, what a service was, logs, very straightforward, right? You can deploy stuff, and let me see here. I can do a kubectl logs. Look at this, the logs for this pod right here. But I prefer Stern because Stern allows me to go across multiple pods. So I can say, hey, look across all the pods. And in this case, there's not much logging going on, but Stern is a phenomenal tool for multiple logs. And then we kind of cover, we'll mention resource limits more in the next section. And then you saw exec in action, okay? And then you saw rolling updates in action, all right? All I did with rolling updates was simply update the image, and you saw it roll through and change. Like if I want to come back over here, kubectl get deployments, and kubectl edit deployment, Quarkus demo deployment. Okay, let's go here. Where's my image? Let's change this to my boot v1, save, close. You'll see it do its rolling update. Okay, more on those things in our second session. We are actually officially out of time today, but we kind of covered most of the material that mattered. I want you guys to, again, have access to the tutorial. Make sure you have that. That's where your homework is. Make sure you get access to the slide deck. You'll notice that in here we have links to the actual individual pages. So if you follow through the deck, you'll see the things I showed you. You can go click on them, go try them out. There's more information on logs here. That's where those links are. But as long as you have access to the slide deck, you have access to the tutorial documentation. You can run the homework. You can come back tomorrow with more questions if you have them. And then we're going to show you the advanced things tomorrow, all right? So this is all the elementary stuff. We show you the advanced things. Let me double check what we have here for questions. So it's either Rail or Rail Atomic Social. Okay, so I'm using Rail Core OS for my worker nodes today. So the worker node is a Rail Core OS. So if I come back over here, since I'm using OpenShift, Rail Core OS is the default. That's what the operating system is that's here. And let me kind of check that out. Okay, so those little VMs are running Rail Core OS. Where'd my little window get lost here? Let's see, little discussion on Istio there. Okay, dun, dun, dun. Installing OpenShift on laptop. Details, so installing OpenShift on a laptop. I see that from Dan there. So you need to go to try.omshift.com. Okay. You need to log in with a developer account. Notice it actually goes to omshift.com try now. Get access to create your own cluster. You got to log in with a free developer account. Create your own cluster. Okay. Laptop. See, it says laptop here. Try it locally. And then come on. I got to log in, and I'm logging in with a funny account called Burzinga, because it is in fact my free developer account. It helps if I remember the password. There we go. Come on now. And right here, you download it, okay? And it gives you the instructions for how to get OpenShift running on your laptop. So definitely check that out. And here I'll provide the direct URL. Direct URL there for you guys. And let me see what else we have here. There'll be a French version next week, a Spanish version next week, an Asia version, an India, Singapore, Australia version next week. And you know what? You'll get a chance to see it all again. Okay. As a matter of fact, we're going to repeat this whole session again in May. You'll see that there too. Okay. Let me see here. Looks like the team here, Alex and Edson and Sebi, did a great job answering all the key questions though. Okay. All right. Feel free to come back and watch the same URL again if you want to kind of pause, play, and also put me on that 0.75%, as I mentioned. That could be a big thing for you to slow me down. Everyone thinks I go too fast, but Edson actually talks faster than I do. Let's just make that clear, okay? Hit me up on Twitter if you have further questions. We can answer them there. You can also got my email address, which is in the slide deck, and we'll be back tomorrow, same time, same place. Well, slightly different URL, right? For another live stream, and we show you the more advanced aspects of Kubernetes and have some fun with it, right? We actually break some things, fix some things, and I think it'll be a lot of fun. I thank you all for your time today. Do make sure you follow closely at DV Master. Okay, follow that closely because we'll be bringing up new master courses as we develop them and as we evolve them. There'll be more content showing up there on a regular basis. So you can kind of see the Istio, Knative, Tekton are coming. These are advanced, by the way. Tekton's super advanced. So you kind of need to be on your game Kubernetes wise to really get your head into these three things. And Tekton is very advanced. And then of course there'll be a cool Quarkus one for that awesome Java stuff that I showed you earlier. I thank you all for your time. And we need to get out of here. You guys have a great day, and let me know if you need anything else. Again, Twitter or email.